And welcome back to the next part of 9, picking up in section 5 with supplementary angles now. Here we go. Looks like, what page are we on here? In your notes, it looks like it's page 16, I believe. Should look like this. We're talking basically now about supplementary angles. Okay, we just finished complementary angles. Complements meant the sum of the angles were 90 degrees. Supplements, the sum of the angles is 180 degrees. So if I asked you to find the measure of the supplement of a 105 degree angle, all I have to do is subtract the 108 minus 105. That would be 75 degrees is the supplement to 105 degrees. Okay, if you want to see a nice visual question of that, here it is. Here is your 180 degree angle right there. So this angle right here is going to be, if that's angle X, it would be 180 degrees minus 112. Subtract that out, and you get 68 degrees is the supplement to 112. Okay. Triangles. All right, triangles, 3 equal sides. Here we go. So moving on from angles into triangles now, we're going to use some of the vocabulary we learned with angles to help understand how to classify triangles. Okay, so one of the things you have to be able to do is classify an angle. And you do that by observing the relationship between the angles of the triangle and the relationship of the sides. Okay, so the first type is, whoops, a little too fast there. An equilateral triangle basically means that you have 3 equal sides. So if you were going to draw a picture, it's pretty much going to look like this. You have 3 equal sides. You also happen to have 3 equal angles there. So that's an equilateral triangle. Okay, 3 equal sides is your key there. All right, if I have 2 equal sides, that's called an isosceles triangle. And here you could have a tall, skinny one. So notice what I'm trying to draw here is if those two were equal and this one was not, now the one mark means that they're equal because they both have 1 right there. That means that's different from those because that has a different number. But they don't have to be tall and thin. They can be short and long. Let's pretend that those are equal. And that's a bad line there, but let's say you got 1 there, you got 1 there, and you got... So that means that these 2 sides are equal there. That's an isosceles when you have that. If I have no equal sides, okay, that's called scalene. So that's any triangle that you could think up that might have 3 sides that are clearly different. 1, 2, 3. So that would be a scalene type of a triangle. Now, so all of those first 3 things there, those are about relationships of the sides. Okay, you got 3 equal sides, 2 equal sides, or 0 equal sides there. Now, the next 3, starting number 4, is going to look at the relationships of their angles. If you have a right angle, like we learned in angles, okay, but if that's a right angle and you have a triangle, we call that a right triangle. If we have a triangle that has an open angle like this, that's called obtuse. And if you have all 3 angles are acute or less than 90 degrees, that's called acute. Okay, and so you can draw your own acute angle as you like. There. Okay? 3 angles, all 3 angles are less than 90 degrees there in an acute angle. Okay, now here's something that is probably going to be on the final for you, as well as the homework and the test. That is a really interesting fact about the triangles, and that is that if you take the sum of the interior angles of a triangle, it always will equal 180 degrees. So in other words, if I have a triangle like this, and it doesn't matter. It really doesn't matter. Let's pretend that's a good triangle right there. And let's say that that's A, that's B, and that's C. That's the measure of the angle. Okay, angle A, the measure, plus angle B, plus angle C. If you added those up, it would always equal 180 degrees, and that's a true fact of every triangle that we will run into. So given that, we can solve problems like this quite simply. If I know that this, okay, this says find the measure of the missing angle, I know that this plus whatever that is has to add up to 180 degrees. Well, it's pretty simple to figure that out. We would take 180 and we would subtract, pick one to subtract there. I'll subtract 65. Okay, if I subtract 65, let's see, it's 7 right there, right? 10, subtract, you got your 5, 6, there's 115. Now I'm going to subtract the 24. All right, 5 minus 4 is 1, and 11 minus 2 is 9, so you have 91 degrees is the measure of x. So that angle is 91 degrees. So if you did the same thing for the other ones, if you took number 2, a little faster way to think about it, if you just want to grab your calculator, 180 minus 61 minus 55, you punch that in, and you get 64 degrees right there. So all based on the fact that the sum of the interior angles of any triangle is equal to 180 degrees. Number 3 did the same thing, 180 minus 31 minus 29. You work that out and you get 120 degrees, I believe. And then the last one, if you did the same thing, I believe we came up with 70 degrees for that for you. So hopefully that's easy enough for you. And that is actually a quick run through 9-5. I'm going to stop it here because the next video we're going to get into square roots and the Pythagorean theorem, and that's probably going to take a little bit of time. I'd rather just start that in a fresh video, and 1 or 2 of those probably, and then we'll be done with chapter 9 quicker than you think. And have a nice day.